Right, guys. So today I thought we'd do this vectors question. It is taken from question 18 of the November 2021 paper 3 for GCSE AQA Maths. I picked this question because it's the transition between the medium difficulty questions and the really hard ones, which is what differentiates the 8 students from the 9 students, and it differentiates the 7s from the 8s, right? So this is the kind of questions you want to be smashing out the park to really access those top grades, which we know is so important for anything you want to do later on in life. Okay, so let's go. So it tells us. I'm not going to read out the question because you can read. You have a brain. You can read it out yourself. But basically, it gives us information about OA, which is this vector here. Sorry, this vector here. It gives information about AB as well, which is good. Then it gives us some more stuff about OC. So OC is obviously this vector here, and it's told us about some ratios. Okay, so my sort of general rubric for approaching these questions is to work out as many things as I possibly can from just an initial view of the problem. Okay, so just using my basic knowledge of vector addition, I can see that if I follow the path from OA to OB, well, that's A plus B, and that's actually equal to OB, right? So OB would be equal to A plus B, right? I'm going to write this to the side so that we don't get confused. Okay, so we have OB equals A plus B. Simple. And then we can dive into the statement which says that D is the point on OB such that OD to DB is 2 to 3. Now we've got to be careful here. It's saying OD to dB is 2 to 3, right? Which means as a proportion of the total length, right? If you think of OD as 2 parts, dB is 3 parts, well, OB being OD plus dB, well, that's going to be 2 parts plus 3 parts, 5 parts, right? So OD is going to be 2 over 5 of OB, right? It's 2/5. So OD, this little bit, is 2/5 of this whole distance here, right? Okay, so I can write that as OD equals 2/5 of OB. Hang on a sec. We already know what OB is, right? We know OB is A plus B. So I can rewrite that as 2/5 A plus B. Cool. So I know that OD is equal to 2/5 A plus B, and obviously the dB has to make up to be a whole. So the remaining 3/5 is taken by dB. So dB is 3/5 A plus B. Nice. Okay. Now we want to sort of deal with the BEEC stuff. And so for that, we need to know what the vector BC is. To work out the vector BC, which is sort of this big vector here, we want to know OC, which we do, it's 3b, and we want to know OB, right? And we know what OB is. OB is A plus B. So we have A plus B here going this way, 3b going this way. Then if you add, right, BC is going to end up being, if I just call BC vector C, A, so if I draw the path in a different color maybe, A plus B plus some unknown vector equals OC. Okay, so to rewrite that, calling vector BC as C, I can rewrite this as A plus B plus C equals 3b. And I can rearrange for C, which gets me 3b minus A minus B, which gives me 2b minus A. Okay, so vector BC is equal to 2b minus A. And then similarly, we can deal with the fractions. We know that if BE is 1 part, EC is 4 parts, then the whole thing BC is going to be 5 parts. So BE is therefore 1/5 of BC, which is the total length. So BE, which is just this little bit here in the green, is going to be 1/5 of BC, which is 2b minus A. So that's 1/5 2b minus A. And then we can work out EC, has to make up the rest, which is going to be 4/5 of 2b minus A. That's this. Okay, so now we've actually done what we said in the beginning, which is work out everything that we possibly can. And now we can actually answer the question. So the question is asking us to find the vector DE. And so if we look at where DE is, it's actually this blue. Let me actually do it in blue. It's a sort of turquoise line here that I've drawn, right? So how can we make DE? Well, if you follow the path D to B, and then we go from B to E, well, that gives us the path DE, right? So if I write this out as, didn't mean to do that, DE equals DB plus BE, or I can just substitute the values I have for DB. So I know that DB is equal to 3/5 A plus B, because remember, OD plus DB equals OB. So DB equals 3/5 A plus B. Okay, and then BE, we wrote down here, I'll highlight it, as a fifth 2B minus A. Okay, so that's a fifth 2B minus A. And then we just compute simple algebra. So collecting the A terms, we have 3/5 A minus a fifth A, which is 2/5 A. We have 3/5 B plus 2/5 B, well, that's just a whole B. Okay, so our final answer is therefore DE equals 2/5 A plus B. Okay, so a general sort of note I would take from this, I'll just write it out, is, so you actually can take away something, because obviously this is a very specific question, but I want you guys to have a sort of a methodology about how to answer these tough questions. I would say, start off with, read Q carefully. Everyone says it, but please do it. Solve for as many unknowns as possible, right? So given the constraints of the question, before trying to go straight to the answer, just solve as much unknowns as you can, right? So in our case, we wanted to find out what OB was, and then from there we found what OD and DB was. We wanted to find out what BC was. All these things were given, and we just solved for them, and everything sort of fell out from there. And then from there, I guess this is sort of vector specific. But pay attention to paths, or to arrow signs, right? Because you need to know that tip to tail is a sum, right? Tip to tail is a sum, right? You got to remember this sort of vector triangle, and from there be really careful to know, for example, this is, if you call this vector A and this vector B, this vector C, A plus B equals C, right? A plus C does not equal B, for example, right? This is incorrect. Just learn your vector addition rules, be really careful with that, and try to find paths, right? So in the case of finding DE, we found a path that was pretty simple, right? We found the simplest path, which was, I'll just go up again, which was going from D to B to DB and then BE, and that gave us DE. But we could, if you wanted to be really annoying about it, we could go reverse of OD, then we could go all along OC and then up to CE, right? And so that would have also led us to the same path. But what's easier to do? Well, clearly this one here, up here, right? So yeah, find the simplest path. I'll write that down as well. Find simplest path. Okay, that's probably quite a long video for you guys, but hopefully it was useful for you to kind of grasp how to solve these vector questions. If you have any questions about what I did, or why I did something, or something isn't quite clear in the diagram, please do let me know. But yeah, crack on with the end of the paper type questions if you guys are looking for top marks. Okay, I'll leave you there. Have a great rest of your day, and goodbye.